Hi there, eighth graders. Um, Yesterday, your assignment was to look at this particular sheet of paper. And actually, I'm going to show you my copy right here. Now, you didn't need to print it out. You could read the information off of the internet and off your computer or your phone, and then you can kind of answer questions. So I thought we'd go through this first of all today to kind of introduce what it is we're doing and see how that works. But this one said that Ralph and Jody go to the shop to buy potato chips and candy bars, and Ralph buys 3 bags of potato chips and 4 candy bars and spends $3.75. And later on, they say that this is the equation that could represent that first piece of information about Ralph. Ralph buys 3 bags of potato chips. So 3P, where P stands for potato chip bags. And he buys 4 candy bars, and that 4 represents 4B here, 4 candy bars. That's the B. So 3 bags of potato chips, 3P, plus 4 bags or 4 candy bars rather, and he spends a total of $3.75. Now, I would have maybe put 3.75 because really it's $3.75, but they said like 375 cents. That's okay too. Jody buys 4 bags of potato chips and 2 candy bars, and she spends $3, right? So that first question there says that if we use P to stand for the cost of a bag of potato chips, and B stands for the cost of a candy bar, what does the 375 in Ralph's equation mean? Well, it means that they spent 375 cents or $3.75. That was the amount that they spent. So however you want to write that there. And then it says, let's write a similar equation using P and B for the items that Jody bought. And we know up here that Jody bought 4 bags of potato chips. So how would we write 4 potato chips? If before they had 3 bags of potato chips and they wrote it as 3P, how could we write the bags of potato chips for Jody? Yeah, hopefully we could write 4P, right? So down here, maybe we put 4P, 4 bags of potato chips. And, so put plus, 2 candy bars. In the equation before, they put 4B because Ralph bought 4 candy bars. So they put 4B. And this time we're looking at Jody, and she bought 2 candy bars. So we should write 2B, to be or not to be. And altogether, before we said that was equal to 375 for Ralph. So altogether, we could say this is equal to what for Jody? Yeah, we can just put 3. I'm going to put 3.0 because I'm going to put that decimal place there. I kind of want to say, yeah, that's money. Let's put it in terms of dollars rather than in cents. Okay. Then it says, use the 2 equations to figure out a price of a bag of potato chips and the price of a candy bar. This is where you had to put your thinking cap on a little bit and think about this. So let me show you one way you could think about it. And excuse me. And I think we could go back to what we did before when we were looking at the cost of hats or baseball jerseys, right? One of the ways they said you could look at this is to make a graph of each situation. And so that's what I'm going to do to solve mine. I prepared myself a little graph here. See if we can go out big enough so you can see the whole thing. So it doesn't really matter on which axis we say. Let's call this the p-axis for the potato chips, and let's call this one the b-axis for candy bars, right? Now, the first equation that we had for Ralph was that 3p plus 4b was equal to 3, and I put 3.75. I'm going to make a small table of values. I'm going to say, let's look at our x and y values. In this case, our p and our b values. And the first thing I'm going to do is say, what would happen, because I get to choose when I'm making these tables, what would happen if I plugged in 0 for my p? Let's just take this opportunity to relate it to real life and say that would mean we didn't buy any potato chips. So if we had this equation, right, but we said we really didn't buy any potato chips, we just bought candy bars, and we bought 4 of them. That would mean that 4 bars cost $3.75. And so on my calculator, I'm going to put that situation in. I'm going to say, okay, well, if 4 bars was $3.75, how would I know the price of 1 bar? Well, to solve this linear equation here, we could just divide both sides by 4, right? So in other words, 3.75 divided by 4 would tell me what B is. That says 15/16. If I use my S/D key, it's about 0.9375, about 0.94, right? 0.94, let's say, okay? And then I could do the same for my y. In other words, I could plug in 0 for my y, in this case, 0 for my b, in which case, if I did that, 4 times b is 0. So this term just kind of goes to 0, which would leave me with 3p equals 375. So how could I solve for p here? Yeah, I could divide both sides by 3. So I can take 3.75 and divide by 3. And that gives me 5/4, or in decimals, about 1.25. Now, in real life, if I said 0 for my B, that means I didn't buy any candy bars, so that 3 potato chips cost me $3.75. This isn't like what it told us that it was. This isn't the situation it told us. It told us how many they bought of each. But I'm saying after we've got our equation down, we can sort of play this what if scenario. We can plug in 0 for our P and say we didn't buy any potato chips. We just bought candy bars and spent $3.75. And then we could go back and plug in 0 for our B and say, what if I just bought potato chips? That means that my 3 potato chips would have cost me $3.75. I realize that's not the situation, but what it does for us is it gives us 2 points. This really is the point 0.94. And I can plot that point. And the second one really is the point 1.25. 0, and I can plot that point, okay? So let's plot the point 0 and 0.94. I've already made out my things. 1.0 is here. Oh, I'm sorry. 0 would be across, wouldn't it? 0.94, got to go to the right axis, is going to be just below 1 here. So I kind of say it's about there. And for the second one, 1.250, 1.25 is here. there's the 0.1.250. So I'm going to get my ruler out. And I'm going to connect these points. Any 2 points that I graph on here, because we're talking about linear equations, are just points on a line. So if I connect those points, I draw the line that I'm talking about. Let's do the same thing for the other equation that we just came up with. We said in our other equation that 4p plus 2b, 4p plus 2b is equal to 3.0. Again, I'm going to make an XY table with my P and my B. So it's a PB table. Peanut butter. Potatoes in bars. Let's go ahead and do our scenarios again. What if we didn't buy any potato chips and all we bought were the candy bars? It says 2B is 3.0. So that means we'd have to take 3 and divide by 2 to find out what B is. That leaves us with 1.5, because 3 divided by 2 is 1.5. And again, we'll do the same thing. We'll plug in 0 for our Y. What if we spent $3 but didn't buy any candy bars? That means that 4 potato chips would have cost $3-ish. And so we'll get our calculator out again. That's 3 divided by 4, which is going to be 0.75, right? Again, the top one is the 0.01.5. The bottom one here is the 0.75. So let's find the 0.01.5. 0 and 1.5 is here. And the other one says 0.750. So it's right there. Let's connect those dots as best we can. All right. Dun, 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 dun. These two lines crossed. Remember what it meant when they crossed before in our Jersey problem? If we graph properly, our Jersey lines would have been the place where both companies were charging the same price. In this case, this place where they cross should give me some X and Y value, right? Which we've labeled as P and B value, which tells us that in both cases, because these people went to the store and bought potato chips and candy bars from the same store, that the price of the potato chips was the same for both of them, and the price of the candy bars was the same for both of them. So really, where these two lines cross should give us an indication of, well, how much did a candy bar cost and how much did potato chips cost? Well, how much? There's a p-value and a b-value. It looks like the b-value, candy bars were a little bit more than 50 cents and potato chips were a little bit less than 50 cents, weren't they? What would be a good estimate for their costs? I might guess that the candy bar, or the price of the candy bars is where it crosses here. That B value maybe is like 0.6. What if it were? We can kind of try some values out here. We know that 4P plus 2B is equal to 3. if I guess that the candy bars were 60 cents a piece, then this would be 2 times 0.6 at 60 cents. I could plug it in there. And then I could kind of get an idea what the potato chips would cost. Let's see what we come up with. 2 times 0.6 is 1.2. So this give me 4p plus 1.2. How do we get p by itself? Well, first thing, subtract 1.2 from both sides. So 3 minus 1.2. If I subtract 1.2 from here, on each side, I'll get 4p is equal to 1.8. And how do we get p by itself? Yep, divide by 4. And so we get 45 cents. So if I were looking at this and trying to figure out, well, I wonder what the cost of a candy bar is and what the cost of a potato chip bag is, my graph tells me that a pretty good guess would be to say that the candy bars were 60 cents and the potato chips were 45 cents. Right? Right. Now, how would I know for sure that that's true? Well, I could go back into the original equation that they gave us for Ralph and see if the numbers work out for that one as well. Does 3 times 0.45 plus 4 times 0.6, would that give me 3.75? That's kind of the question. If I plug those values in, if I put 0.45 in for my p, because remember Ralph's equation was 3 potato chips plus 4 candy bars was 3.75. So if I'm using the guess from my graph of 45 cents per potato chip bag and 60 cents for a candy bar, let's see how close we get here. 3 times 0.45. If I get my fingers to cooperate, is $1.35 plus 4 times 0.6, which is $2.40. And you add 2.4 plus 1.35, and we get 375. So we were correct. We were able to determine from the graph a reasonable guess and confirm it by plugging it back into the equations. So I would definitely say that it looks like the price of potato chips is 45 cents, and the cost of a candy bar is 60 cents, because that's what it looks like on my graph. Bars were about 60, somewhere between 0.5 and 0.75. And potato chips were a little bit less than 50 cents a piece, 45 cents. It was a pretty good guess. We got it. Okay. All of this, right, is what my explanation for my guess was. What we've just done is we've solved a system of equations by graphing. On page 148 of your textbooks. That is exactly what we're going to do for this section. In chapter 5, we're going to deal with what are called systems of equations. To be more technical about it, it'd be systems of equations in two variables. Typically for us, it's going to be x and y. And the first method that we're going to do is called solving by graphing. There are a lot of times in this world where we need to find out where two things are the same, whether they're hats or costs of hats or costs of jerseys or costs of candy bars and costs of chips. Sometimes we're looking for costs. Sometimes we might be looking for profits, like if you're making money. But an application of math would be to solve a system of equations, and you're going to have information, but you don't necessarily have all the information. But we can use systems to find the things we don't know. Typically, what we're going to do is end up graphing two lines and really saying, where do they cross? Just as we did in this problem. We would come up with an equation for each situation, graph those situations to see what points they have in common, and come up with a solution to the system. Let me show you how it works on your using your problems from your book. For example, the first one it tells us is that we've got an equation y is equal to 2x minus 1, and a second equation that says y is equal to negative x plus 5. Okay? What we want to do is graph these, but I want you to know that both of these fit that one little mold, y is equal to mx plus b, which we call slope-intercept form for a line. And remember, m is your slope, and b is your y-intercept. And that's going to make things pretty simple to graph. Let's give it a shot. I'm going to make myself a little coordinate system. Remember, here's your x-axis, here's your y-axis. And let's graph this first one. It says y is equal to 2x minus 1. Remember, the number that comes before the x is always going to be your slope. So we know the slope on this one is 2. And the number that's sitting out here all by itself is your y-intercept. So we know that it crosses the y-axis at negative 1. Again, these are important concepts, and make sure you understand these. We're going to be doing this for a whole bunch. But anyways, at negative 1 on the y-axis, I'm going to put a dot. And from there, I'm going to go up by 2 and over by 1 because 2 is my slope. Remember, slope is your change in y over your change in x. And in this particular case, your slope could be written as 2 over 1 because we can turn any number into a fraction just by putting 1 underneath it. So we can create our slope fraction just by putting a 1 underneath any whole number that we might have in front of the x. So always, first of all, plot a point on the y-axis that's given to us by the b value, the number that's over here. This number right now is negative 1. So on the y-axis, I find negative 1 and I put a point. That's where we start on each one of these. And then from there, we're going to use our slope, in this case 2 over 1. The top number tells us how far to go in the y direction. The bottom number tells us how far to go in the x direction. So from this point, it says let's go up 2 and over by 1. So from here, I'm going to go up by 1, 2, and over by 1, and put my next dot. It's pretty handy and helps us draw nicer straight lines if we do that a couple of times. So from this point, again, I'll use my slope to go up by 2 and over by 1 and put yet another dot. And then I'll use my straight edge, yes, get a ruler or something that draws straight edges and connect those dots. Why straight? Well, we're trying to figure out where the lines cross. And if your lines are crooked, it's going to be really difficult to see where they cross. So here's my first line. Let's do the second line. Again, the first thing you have to do is use the number over here and mark that on the y-axis. At positive 5, I'm going to put a dot. So on my y-axis, I count up to 1, 2, 3, 4, 5, and I put a dot. Excuse me. From there, I go back and look for my slope. Now, there's a negative sign in front of this x. And if you'd like, you can put a 1 in front because there's just one x there. And if it helps you think about the number 1, you can actually draw it. So that says my slope is negative 1. Again, that's my change in y over my change in x. So if it helps, you can think of that as a negative 1 over 1. We can always create a fraction, a slope fraction, by putting 1 underneath the whole number that's in front of our x. Okay? Excuse me. So what I'm going to do is from here, from the y-intercept, from the place I put my dot, I'm going to go down 1 and over by 1. Down by 1 and over by 1, put a dot. Do it a couple times. Down by 1 and over by 1, put a dot. After you get 3 dots on there, connect them up with your straight edge. Again, keeping your lines as straight as you can make them. So we want to see, like, where do these actually cross? And it's hard to tell if you don't draw nice straight lines. But line up your dots. Connect the dots. And we can then try and figure out where these crossed. To me, it looks like they cross right there. Now, the answer is not to circle where they cross. You don't go, oh, I see it's there. No, we actually need to know what that point is. So we'll count. You go over in the x direction first because remember, all of our coordinates are in terms of x, y. So we're going to count over 1, 2 in the x direction and up 1, 2, 3 in the y direction. That is the point. 2, 3. That is our solution. When we're solving systems of equations, we're asking the question, where do the lines cross? What point do they have in common? And the answer is going to be a point in XY form. The point 2, 3 is the answer. It's written as an ordered pair. That means that you're going to use parentheses, right? And inside those parentheses, you're going to write the x value first, put a comma, write the y value second. Again, inside parentheses, you're going to write your x value first, put a comma, then write the y value. So when you find it on your graph, you're going to write the x coordinate, then the y coordinate separated by commas, and put a parenthesis around it so that it looks like the ordered pair we're looking for. This is the correct way to give your answer. Make sure you give it in this form. That's important, okay? Perfect. That's how you solve a system of equations, by graphing. But, you know, if life was simple, we'd start there. But sometimes life just isn't that simple. I put the wrong thing. So my life would have been simpler if I'd have written the right thing first there, but I didn't. Let's erase it and put the right thing. Y equals 2 and 2x plus y equals 1. All right, so here's a new system. Solve the system by graphing, says the book, but it didn't give us the equations the way it did before. Before, it gave us equations that looked like y equals mx plus b. And then when it gives us equations in that form, we, first of all, plot the y-intercept on the y-axis, and then we go back and read the slope and count from there your change in y over your change in x to give us additional points that we can connect with lines. Wonderful. But notice, these are not in that form. Instead, the x and the y are on this side, and there's a constant on the other side. This is really called standard form. Not that that's important to us at the moment, but we do graph things differently, or we have to graph things slightly differently, or use a different method to graph them. remember from the chips and candy bar worksheet, I said, oh, I'm going to graph these and make lines out of them. And what I did to do that is I made a little table of XY values. In this case, they were P and B values, but what I did is I said, oh, I get to choose numbers to plug in for my X and see what I get for my Y. And then I plugged in a number for my Y to see what I'd get for my X. It really only took 2 points to find, so I could plot them. That's because I know of a special method that's called graphing by intercepts. And in order to do that, for my first equation, I'm going to write a little table down. And I'm specifically going to choose values that are 0. In other words, I'm going to say, what happens when I plug 0 in for my X? This is what happens. For this equation, X minus Y, if I plug in 0 for my X, so 0 minus Y equals 2, that would reduce into negative Y is equal to 2, right? Because I don't have to write 0. 0 means nothing. 0 means there is nothing there. So if there's nothing there, I'm not going to write it, and I just get negative Y is equal to 2. If I were solving this, like I've solved equations in the past, excuse me, I could divide both sides by negative 1 to get Y equals negative 2. What that tells me is that when I plug in 0 for my X, my Y will be negative 2. So I'm going to write that in my table. And now I'm going to do the same thing, except for this time, I'm going to plug in 0 for my Y. So I'll write 0 for my Y, and I'll rewrite this equation now as X minus 0, because I'm plugging 0 in for my Y, equals 2. I'm just plugging 0 in where the Y was. Just like in the previous one, I plugged in 0 for where my X was. Right? Right. Okay. So if I don't subtract anything from X, I get a 2. So I'll just write that as X equals 2. That means that when Y is 0, X has to be 2. So I'm going to write that there. How does that help? Well, like I said before, these turn into points. This is the point 0, negative 2, and I can graph that. And this is the point 2, 0, and I can graph that. And after I graph both points, I can connect them with lines. And that's what we're going to do. But before we get there, let's also make a table for my second one. X and Y values for my second equation. What should I plug in for X? Say 0. Say 0. Did you say 0? One more time. What am I going to plug in for my X? 0. Okay, good. So I plug 0 in for my X. If I do that, I'm going to rewrite this equation. 2 times 0 plus Y equals 1. What is 2 times 0? That's 0. And so I get 0 plus Y equals 1. But I don't really have to write my 0, do I? That's just Y is equal to 1. So that tells me that when I plug 0 in for my X, my Y is 1. And I'll fill the table in. We'll do the same thing. What should we plug in for Y? Say 0. Let me ask the question again. What should we plug in for Y? Say 0. Say 0. It's 0. Say 0. 0, you said. Good. We're going to plug in 0 for our Y and see what we get. So I'll rewrite this equation. 2 times X plus 0 equals 1. Well, 0 is nothing, so I'm just going to write 2X is equal to 1. Now I want to get X by itself, so divide by 2. What? Divide by 2. Do what? Divide by 2. Okay, we're going to divide by 2 on both sides. These 2's cancel, and X is equal to 1/2. So I'm going to write 1/2 in up here. 1/2. Here we go. We're going to make a graph. Let's make a graph. So here we go. We're going to draw our coordinate system. Up and down axis is the y-axis. One that goes side to side is called Did I just say the x-axis? The one that goes up and down is the y-axis. The one that goes side to side is called the x-axis. Come on, Mr. Fokin, you know better. And axes have arrows on the ends of them. You know why? Because they keep going. That's why. Where they cross, that's the point 0, 0, also known as the origin. If I was going to graph the points now from my tables, let's go back up to this table here, the first one I had. It says graph the point 0, -2. So on my x-axis, I go to 0, and on my y, I go down to -2, and I put a dot. That's the point 0, -2. Graph the next point. It's 2, 0. That says on the x-axis, go to 2. On the y-axis, don't go anywhere. And there's the point 2, 0. Using your straight edge. Why straight edge? Because if you want to figure out where the lines cross, you got to make straight lines. That's why. So we're going to graph that line. It's got arrows on it because it keeps going as well. And there's my first line graphed. Here comes the second line. You ready for it? Here it comes. We're going to go back to our table and graph the point 0, 1 from this table. So this says don't go anywhere on your x-axis. Just stay at the origin and go up by 1. Boom. There's the point 0, 1. And we'll graph the second point, which is the point 1/2, 0. So on my x-axis, I'm going to go over to 1/2 and don't go anywhere in the y direction. And that's the point 0 or 1/2, 0. And we'll connect those with a straight edge. Why a straight edge? Because we want to know where the lines are crossing as best we can. This doesn't make any sense. I got to go. I'm not connecting very well. No, I'm not connecting well at all here. If I go through the halfway point, and 1 over about 1/2, down 1 over about 1/2, I got right there. That's where these go. Okay. Ta-da. Again, use a straight edge. Make sure you draw nice straight lines. And I see that my graph looks like it's crossing right there. What do we call that point? We call that the answer. And what is the answer? The answer in this case is 1, -1, because I go over by 1 and down by 1. That's 1 in the x direction, -1 in the y direction. That is the point 1, -1. That's my solution to that. That's my solution to that system. Okay? What did we just do? It's called solving systems of equations by graphing, okay? This is systems of equations. I should say plural here. These are systems of equations, solving by graphing. If they're in y equals mx plus b form, you can use the y-intercept as well as the slope to find your points and draw your lines. Then you look to see where they cross, and that's your answer. If they're not in slope-intercept form, then they're probably in standard form. That's where your x and y are on the same side. Like have x minus y equals 2. See, the x and the y are on the left. The non-xy term that we call the constant is on the right. Same thing's happening here. Our x and y terms are on the left and our constants on the right. When you have something like that, it's called standard form. And when they're in standard form, we're going to graph by intercepts. That means we're going to make a little table of values, but we're just going to plug in 0. So first you plug in 0 for your x, see what your y is. Second, you plug in 0 for your y to see what your x is. Then you'll plot those 2 points, connect them with a line, do the same for both equations, and where the lines cross, well, that's your solution to your system, okay? We are solving systems of equations by graphing, and you'll need a pencil. Pens work, but when you make a mistake, it's awfully hard to erase them. You'll need a straight edge, and if you have graph paper, that's great. If you don't have graph paper, kind of make your own, you know. Let me show you what I mean. If I was going to make a graph and I didn't have graph paper, but I did have a ruler, I would say, okay, I'm going to make my axis, but while I'm doing this, there's like numbers and stuff, right? So I'm going to draw my line, but then I'm going to go in here and, like, for example, on the centimeter side of the ruler, I'm going to mark off every half centimeter. Hopefully you recognize that halfway between 5 and 6, there's a little bit bigger mark, so it shows me where the halfway point is. So I'm going to mark off half distances on my line that I just drew. Okay. And so if that's my y-axis, I've got like a nice little equally spaced dot system. And then like through one of those dots, I'm going to line up so that I can draw my other axis here. This would be my y-axis or my x-axis. And again, mark it 8, 8.5, 8.5, 9. I'm counting up as I go here, right? 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15, 15.5, 16, 16.5, blah, 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 right? Okay, so now I've made a coordinate system without graph paper and actually have marks on my lines where I can go, okay, here's a 1 and a 2 and a 3 and a 4 and a 5 and a 6 and a 7 and an 8. And if you need to make longer lines, make longer lines. Up here you can count 1, 2, 3, 4, 5, 6, and so on if you need to make longer lines. And down here you can count a 1 and a 2 and a 3 and a 4 and a 5 and a 6, and these are negatives. And then back here you can count a 1 and a 2 and a 3 and a 4 and a 5 and a 6 and a 7 and an 8, and these are also negatives, so we can mark them right there on our graph. Now when you make your plots, you can now have nice even division, so you can count and use your ruler to make straight lines with a nice graph. Don't just draw it by hand. This is not, making your own little graph thing and go, oh, here's X or here's Y and here's X. And oh yeah, I plotted this, and oh yeah, I plotted that, and I drew a straight line, and then I plotted another one, and I drew a straight line, and I said, oh yeah, they cross it. Like, I don't know. Now, freehand, while it looks cool and it makes you feel good that you can almost draw a straight line, is not what we want to do. We want to use a straight edge, and if you're going to make your own graph paper for each one, which isn't too hard to do, mark off the little digits off your ruler so you have even divisions. If you have access to graph paper, make sure that when you draw your coordinate system that you're actually on a grid line and that they cross at the corner of grid lines. Yes, yes. And then you can count over, this is 1, this is 2, this is 3. Okay? Don't freehand it. Don't go, oh, close enough. No, we want to be exact in our drawings, or as exact as we can be. Anywho, that's how you do these. Try some on your own. The assignment is given. Good luck to you. We'll talk to you soon.